Continuity. A continuous function is a function whose outputs vary continuously with the inputs and do not jump from one value to another without taking on the values in between. The proper notation is the limit of f of x as x approaches c equals f of c. When there is a hole, the limit of the value exists. However, when it is evaluated, the value does not exist, as shown here. For this piecewise function, we're going to evaluate both pieces as x approaches 2, as shown here. This limit is already done because the limit of f of x equals 4 as x approaches 2. This one, we plug in 2 for x, so we get the limit of f of 2 equals 3 minus 2 as x approaches 2. And so the limit of 2 as x approaches 2 equals 1. So we know that there is a hole because these values are not the same. When we look at the graph, it can be told that there is a hole at x equals 2 because there is an open value and then a point at y equals 4.
This is the graphical approach for a jump discontinuity. We have the function f of x equals 5 minus x for all values less than 4, and x over 2 for all values greater than or equal to 4. In the graph, you can see that the right-hand limit and left-hand limit, when x equals 4, are not the same, but they both exist. Therefore, it's a jump discontinuity. Oh, wow. That's clever. Must have been one of the kids from the 4th period class. Wow, that's probably one of the best student things I've seen. Vertical asymptotes. Algebraic. We have the function f of x equals 2 over 3 minus x. When we plug in 3 for x, the denominator equals 0, so it does not exist. However, the limit does exist. The left-hand limit as x approaches 3 is infinity, and the right-hand limit when x approaches 3 is negative infinity. This is how you know algebraically that you have a vertical asymptote. The graphical approach. We have the function f of x equals 1 over x minus 2. If we plug in 2 for the denominator, we get 0, so it does not exist. You can tell from the graph there's a vertical asymptote because the left-hand limit at x equals 2 is negative infinity, and the right-hand limit at x equals 2 is infinity.